All right, you guys, this is the day 3 notes with some instruction as well as examples 1 through 4. So what I'm going to explain first is the fact that we are doing limits algebraically. So what that means is the first thing we always want to do is to plug in C. Now the format for this would look like a limit of x going to c of some function. That's what we're going to actually be doing. So when it says plug in c, and then it's going to tell us what to do next. If we actually get a number or a value, then it is continuous at c, and then that is what the limit is. Now if you plug in c and you get something called an indeterminate form, which is when it is 0 over 0, then you would have a hole. And you need to use algebraic techniques so that we can actually find the limit. And these would include possible expanding, factoring, conjugates, clearing denominators. So this, you guys, is when all of that practice of Algebra 2 pre-calculus that we've already done this year really gets ready to help us. So after applying this and we no longer get the 0, 0, you plug in the value into what you are left with and you get the limit. Now, if for some reason you cannot get what the value is, you can always look at a graph or a table. And then the next thing is if you end up with a number over 0, if you recall, trying to divide by 0 means it is undefined. And there would be a vertical asymptote right there. When there's a vertical asymptote, it does not exist. All right, so let's go ahead and look at examples 1 through 4. So we're going to talk about what we do, what we check, possible different process that we used or different technique. So the very first one, let's just say right here, we plug in that value that we're finding the limit to. And yes, this gives us a value. 36 minus 9 plus 1, 28. So your limit is 28. So what did we do here? We plugged in C and we ended up with a value. And since that is true, we know that the function is continuous. When, number 2, we plug in the negative 2, we get the value 0. Now, is that the same thing as 0, 0? No. This is the limit. So when we plug in C, we get a value. Taking a look at example 3. Now, if you recall a function that just has a constant, if you remember, that is a horizontal line. So no matter what we are taking the limit approaching, it is always going to be that 17. So in this case again, we plugged in C, and there's actually nothing to plug in, so it's just always the constant. The next one, we are going to put the negative 2 in and see what happens. So I would have negative 2 squared minus 4 over negative 2 plus 2. And if you notice, that gives us 0 over 0. So what does that tell us? We have more simplifying to do. So if you have something that is squared like this, chances are you are going to need to factor. We end up with, now let's go ahead and write it in this form because we are reducing the function. This is difference of squares. And if you notice, the x plus 2's, if we reduce those, they go to 1. We are left with this. And where we have x minus 2. Plug in that minus 2, and we get -4 for our limit. Now the thing you also want to realize is that means there is a hole. So we plugged it in initially. We end up with a 0 over 0. We factored, and we ended up with a value. Now the thing to consider here, you guys, it is discontinuous, and it has a hole. So what is the coordinate points of that hole? If you recall from pre-calculus or even algebra 2, when you have a hole because of that simplification, you would just plug in your c value into the remaining function, and you get the x and the y of the hole. All right, see you next time.